In this video, we're going to go over practice problems on how to identify which reactant is undergoing oxidation and which reactant is undergoing reduction. At any time in this video, if you want to pause and then do the problem yourself and then unpause and then see how you did, that would be great. Okay, so let's go ahead and just do some practice problems. Okay, here's our first practice problems. Remember, we have the three viewpoints. We're looking at oxygen, hydrogen, and electrons. So in the first reactant, we have zinc and oxygen. So over here, we're going to compare it with the zinc because we want to compare zinc and then look at what's happening with either the oxygen, the hydrogen, or electrons. So here we have oxygen. On this side, we don't have oxygen, so we can say lost oxygen. Lost oxygen is reduction. And then let's look at the other reactant. We have hydrogen. We're going to compare that to the water. So here, hydrogens are the same, but on the product side, we've gained oxygen. So gained oxygen and gaining oxygen is showing oxidation. So remember, with redox reaction, one reactant has to be oxidized and one has to be reduced. And if that does not happen, then you do not have a redox reaction. Okay, next example is our hydrogen and oxygen to water. So sometimes we only have one product, and so we're going to compare both reactants to that one product. So the first thing is hydrogen. We're going to compare that to the water. Again, remember, we're not looking at coefficients at all. So here we have two hydrogens, that's the same. No oxygen, one oxygen, so we can say that we have gained oxygen here. Oh, that is not a 0. That is just an O. So we've gained oxygen. Gaining oxygen is oxidation. Let's now look at the oxygen, and we're again going to compare it to the water because that's all we have. Here we have gained hydrogen, and our oxygen went from a 2 to a 1. So that 2 to 1 means that we have lost oxygen. And when we look at that, hopefully they're the same viewpoint. Losing oxygen, gaining hydrogen is reduction. So oxygen is reduced in this example. Okay, next example. Let's see. Let's skip one. Okay, good. This next one is the combustion of propane. Let's go ahead and look at this one. So propane, we're going to compare that to the carbon dioxide. Here we have 8 hydrogens, no hydrogen, so we've lost hydrogen. And then over here we have no oxygen and 2 oxygen. We've gained oxygen. Let's hope those two viewpoints correlate with each other. So losing hydrogen, gaining oxygen shows oxidation for the propane. And then the oxygen, we're going to compare that with the water. So here we have gone from 2 oxygen down to 1. So that shows that we have lost oxygen. We've also gone from no hydrogen to 2 hydrogen, so we have gained hydrogen. So here, if we lose oxygen, gain hydrogen, this shows reduction. Okay. Next example. This one, notice we have no oxygen and no hydrogen, and so we're going to look at oxidation numbers. So here we have our iron and our iron ion. So oxidation number of any element by itself is 0. When it's a monatomic ion, it's just the charge of the ion. So this went from 0 to 2. That shows an increase in oxidation number, which means that we've actually lost electrons here. So an increase means we've lost electrons. If we lose electrons, then that shows oxidation. Okay. So remember, oxidation is loss of electrons, and we can show that because our oxidation number is increasing. And then the copper 2 compared to the copper atom. So right here, +2, this is the monatomic ion. The oxidation number for copper by itself is 0. So this one went from a 2 to a 0. So that shows a reduction or a gain of electrons. So right here, we gained electrons, which means we just showed reduction. Remember, that seems kind of weird and strange, but it's because electrons are negative. So when we gain electrons, things become more negative they get reduced. And when we lose electrons, things are becoming more positive, which is oxidation. Okay. Next example, this one looks kind of scary, but this one is CH3CHO plus hydrogen peroxide gives us acetic acid and water. Let's go ahead and compare this one. So let's look at the first one, CH3CHO. We're going to compare this because it has carbons to the substance on the product side that has carbons. So here, let's look at what's happening. Okay, we've got 4 hydrogens. Here we only have 4, so hydrogens are the same. Here we have 1 oxygen, and here we have 2. So we have gained oxygen on this side. We gain oxygen, that shows oxidation. And then let's compare the hydrogen peroxide to the water. Here are hydrogens, we have 2 and 2, those stayed the same. The oxygen went from a 2 to a 1, so here we have lost oxygen. Losing oxygen shows reduction. Okay, that one looked kind of scary, but it really wasn't, which is good. Okay, next example is another combustion. So on this one, we're going to compare our methane to our carbon dioxide, and we're doing that because they both have carbon in them. So here we have 4 hydrogens, over here no hydrogen, so we have lost hydrogen. Over here no oxygen, but over here we've gained 2. So we have gained oxygen. So hopefully these 2 viewpoints go together. So if we look at lost hydrogen and gain oxygen, these both show oxidation occurring. Okay, now let's look at our other element. Here we have oxygen, comparing it to the water. Remember, we're not looking at our coefficients when we're doing this. Okay, so here we have 2 oxygen. Over here we only have 1, so we have lost oxygen. Then over here we have no hydrogen, but over here we have 2. We've also gained hydrogen, so let's hope those 2 go together. So here is loss of oxygen, gain of hydrogen, that shows reduction. Okay. Another problem we have here is one where we have only one product. So here, let's check things out. We've got iron, and then our iron oxide. So again, whenever we have one product, we're going to compare both reactants to that one product. Okay, so right here, our iron. We have just iron over here. Over here, we have gained oxygen. And again, we're not looking at those coefficients. Okay, so we have 3 oxygen. So right now we have gained oxygen. Gaining oxygen is oxidation. Okay, now let's look at what's happening with our oxygen on the reactant side. So here we have 2 oxygen. Here we have 3. So this one is gaining oxygen. Okay, remember gaining oxygen is oxidation, but we have a problem here because the iron is also oxidized. So remember, when this happens, we can't have 2 of the same viewpoint. We can't have 2 oxidation and no reduction. We have to have 1 of each. So again, what you're going to do is you're going to look at ratios. So right here, we're going to reduce this iron 3 oxide down. So we're going to divide by 2. So when we divide by 2 here, okay, that reduces that to 1. And then if we divide that by 2, it's going to give us a 1.5. This is like saying we have FeO with a 1.5. Okay, so that's our ratio now. 1 iron to every 1.5 oxygens. So now looking at that, let's compare the oxygen again. We have 2 oxygen here, and here we only have 1.5. So that shows actually a loss of oxygen, and a loss of oxygen shows reduction. So now this redox reaction makes sense because we have oxidation and we have reduction. So again, when that happens, use your ratios and compare the same to the same. Okay, I hope that helps. And if you have any other questions, let me know. And I think that is it. Let's make sure. Yep, that's the end. Okay, bye.